Hi, this is another example to find resultant force and resultant moment for 2D application. In this one, we're going to use scalar method to solve it. The picture given here is already free body diagram. So with the question, so all we have to do is draw it down like it is, and then we have the free body diagram. Just to make sure we understand the same thing. This is now, this is free body diagram already, right? Now, to make our life easier and so that we can communicate on the same level, so we'll designate what is x and what is y so that we can talk the same thing, right? In this case, I will have x to the right hand side positive and y up down, whereas up is positive. With the scalar method, we solve with one axis to another. Again, we start off with sigma fx. We assign everything, we assume that this result is right hand side positive here. Then, the first one we look at is the 8 kilonewton. 8 kilonewton going up and right, therefore this is x, we care only on the right, therefore it's 8 positive cosine 30 degree. Then the next one is the 20. The 20 is in fact go to the left hand side, therefore it minus 20 cosine 45 degree. That one all combined become minus 7.212, which actually mean 7.212. This is kilonewton, this is kilonewton, therefore kilonewton. To the right hand side positive, this is negative, therefore to the left hand side. So that's our first equation. Sorry, this is sigma fx. Next is of course sigma fy. Then sigma fy, in this case upward, let's call upward positive here. Okay. Now the first one here is the 8 kilonewton. 8 kilonewton, if you see, is going up, therefore positive of 8 is 8 sine 30 degree. Then the next one is the 20. 20 is also going up, so that it's positive of 20 sine 45 degree. These two combined then is equal to 18.14, which is in fact 18.14 kilonewton positive mean upwards. Similar to every time, when we talk about resultant force, we want one value, not two different values. So I will note it here, and then we can calculate the next step, right? So sigma fx here is equal to 7.212 kilonewton to the left, and sigma fy here is equal to 18.14 kilonewton upwards. Okay, I will clear this out, and then we can start calculating the next step to combine these two forces into one so that we can get to our answer. Now, we will combine these two forces into one, the usual step of calculation. Then we get the picture help. Sigma fx to the left hand side, 7.212 kilonewton. And then we have sigma fy going upwards here of 18.14 kilonewton. Then we add into the box, and then here we are having resultant force here, sigma f. Using Pythagoras, then we have sigma f is equal to 7.212 square plus 18.14 square overall in the square root. That one come out to be 19 0.52. The direction, of course, is that way, up and left. However, again, this is not specific enough. Therefore, we assign the angle theta so that we can actually be specific on what angle it does to the x-axis, to the horizontal line. Now, theta is equal to, using that triangle, that is 7.2, 12, 18.14, that one is arctan of that side divided by that side, which is 18.14 over 7.212. Using, of course, calculator, you should end up with 68.32 degrees, which means our first answer, the resultant force is sigma F is equal to 19.52 kilonewton. That way, with the angle of 68.32 degrees. Now, this is not the only answer we have to find, so we also need the moment calculation. I will get rid of this so that we can do the moment calculation here in place of this. Now it's time for us to solve for the summation resultant moment, or well, summation of moment, okay, about point O, of course. So the name, as usual, we'll start with the pattern we know. Sigma moment about point O is equal to, well, let's say anti-clockwise positive, right, to make our life easier. Well, let's start with the force of 8 kilonewton first. 8 kilonewton, of course, has two components. The first component, let's talk about the x direction. If I take it that way, it is actually 8 cosine 30 degrees. Then, about point O is rotate to the right hand side, rotate this way, which means it is clockwise. Therefore, that is minus the arm between point O and 8. From here, don't forget we are talking about this force. So the distance we're talking here is up and down, vertical. So from here to here is 2.5. That's the first component done. Then the 8 also has another component here, this way the vertical one, which is 8 sine 30 degrees. If I part point O and push this one upward, it rotates anti-clockwise, therefore that is positive. That 8 sine is actually vertical. Distance we measure is left and right. Sorry. Perpendicular distance is left and right. In this case, 1.5 meter. Right? Then we have the 20. In the x direction, it is 20 cosine 45 degrees. It pushed that way, about point O is rotated anti-clockwise, therefore it's positive. The 20 cosine, which is x direction, is horizontal. The distance is vertical, therefore is 0.5. Then the last one is 20 sine 45 degrees, vertically. This one here, the 20 sine is actually pushing upwards, therefore it's rotated again anti-clockwise. Distance is 2, so plus then times 2. All those negative and combine and it's becoming 24.03. The unit of all forces is kilonewton. The unit of all distances is meter. Therefore, that one means 24.03 kilonewton meter. Since we assume the summation of moment is anti-clockwise and it's positive, meaning we assume correctly. So here we add that one. So again, this is not really the answer yet, and our answers in word. So I will make notes and then we'll answer it with wording. Summation of moment is 24.03 kilonewton meter anti-clockwise, right? We just put that in words and we are done. Now, to do that, I will have to get rid of this point first. So, I will take it out in a bit. So now we have our note here. Is now we're going to put this into wording for our answer, right? So we have the resultant force. The resultant force is 19.52 kilonewton left and upwards with an angle of 68.32 degree to x-axis. And we also, that's the answer. Then we also have the resultant moment is 24.03 kilonewton meter anti-clockwise, or I think in American it's called counter-clockwise. I will take both, and then this is also an answer. So again, we have two answers with this type of question: resultant force and resultant moment. Resultant force have the magnitude, the unit, and the angle. Direction and the angle. Resultant moment have the magnitude, the unit, the direction. Again, there is no rotation left, no rotation right. It is rotating anti-clockwise or clockwise. And these are the two answers. Thank you very much.